From careful tree felling in Washington's deep forests to precision thinning in Georgia pine stands, this is timber handled with purpose. Watch logs move from forest planning to transport, milling, and energy production. Every cut protects value, every step follows a plan. From raw trees to finished wood products, this is the full timber journey, built on control, patience, and respect for the material. Quality comes first during large-scale logging operations in Southwest Washington. Out here, the goal isn't to move fast or chase numbers. It's about preserving the full value locked inside every tree, even while working across steep ground, shifting soil, and dense, heavy timber. Each decision carries weight, because once a tree falls, nothing can undo what happens in those few seconds. That understanding shapes the entire operation long before a saw ever touches wood. The terrain alone demands respect. Slope land changes how force travels, how momentum builds, and how impact transfers through the trunk. Instead of letting gravity dictate everything, the environment is shaped to work with the fall rather than against it. A prepared stack of logs sits waiting along the slope, positioned not as a shortcut, but as a safeguard. When a mature tree begins its descent, the raised surface allows the butt to lift and clear uneven ground that would otherwise twist or snap the lower stem. That single choice protects more than what's visible from the outside. Inside the wood, fibers remain aligned. Pressure spreads gradually instead of collapsing all at once. The trunk absorbs movement instead of fighting it. Even the crown benefits, settling with less violence, reducing the sudden shock that often fractures valuable upper sections. What looks like a small adjustment ends up preventing losses that might never be seen until milling. Throughout the fall, direction matters just as much as timing. The elevated position keeps gravity working evenly along the length of the tree, rather than forcing the top downward first. That brief pause in motion makes a meaningful difference. Instead of a sharp break, there's a controlled transfer of weight. The tree doesn't crash. It arrives. Patience defines the rhythm here. Trees of this size demand restraint, not force. There's no rushing the moment when thousands of pounds begin to move. Every angle, every contact point, every inch of clearance contributes to how the wood survives the impact. The crew's focus stays quiet and deliberate, watching how mass and balance interact in real time. Once on the ground, the results speak for themselves. The trunk remains long, clean, and structurally sound. Fewer fractures mean more options later. Better grades, longer sections, higher value applications. What's preserved now carries forward through transport, milling, and final use. Waste avoided here echoes far beyond the hillside. Daily production may move slower, but the trade-off is intentional. There's a noticeable calm when a massive tree settles without a violent snap. It's the sound of material saved, not lost. That restraint reflects a larger philosophy, prioritizing recovery over volume, value over speed. By the time the area is complete, the difference becomes unmistakable. Logs show consistency, strength, and length that would otherwise be impossible on terrain like this. At scale, those saved inches and intact fibers add up fast. In the long run, careful felling proves its worth every time solid. Undamaged timber reaches the landing, whole, usable, and ready for what comes next. A late-stage thinning operation moves quietly through pine stands in west-central Georgia. At this point in the forest's life, every decision shapes what these trees will eventually become. The focus isn't removal for its own sake, but refinement, guiding the stand towards saw timber while preserving strength, spacing, and crown balance. The crew advances with intention, working between established rows and keeping pressure off surrounding trunks. Machines hold their position carefully, allowing movement without transferring stress through the stand. That restraint defines the pace, and it shows in how little disturbance spreads beyond each fall. When a tree finally goes down, it settles into open corridors formed earlier in the rotation. Bark remains intact, stems stay straight, and neighboring trees are left untouched. Even the extraction follows that same discipline. Logs move along planned paths, avoiding new scars in the soil or roots. What remains behind still feels stable. Slash lies low, helping retain moisture and protect the ground. This thinning likely marks the final pass before maturity, a quiet transition from management to growth, where the forest is left to finish the work on its own. Operators return to the Georgia logging site with a different objective guiding the day. This time, the emphasis isn't speed or volume, but steady removal carried out with intention. Trees selected earlier are reached through cleared lanes that keep equipment moving freely, without leaning pressure against the surrounding stand. The forest already shows signs of planning done well in advance. Across the rows, machines position themselves with purpose, shaping how each fall unfolds. Direction matters here, not for efficiency alone, but for preserving the form of the timber. Trunks settle cleanly, avoiding the twisting forces that can quietly reduce value long before milling ever begins. The work feels measured, almost restrained. Once on the ground, stems are brought into manageable form and gathered for movement. Extraction follows familiar paths, with skidders tracking roots that protect soil structure and leave root systems undisturbed. Each pull looks deliberate, strong but controlled, stopping just short of excess. There's a rhythm to it that keeps the stand intact. As space opens gradually, light begins to filter deeper between the trees. The forest doesn't feel thinned aggressively, it feels relieved. Growth potential becomes visible with every cleared corridor. By the end of the pass, the site appears calmer rather than emptied. What remains stands with room to strengthen, and what leaves does so in far better condition for the mill ahead. Instead of pulling stumps out, Dipper Fox crushes them in place on excavators at Rober Hire in New Zealand. Mounted solidly to the machine, the crusher drives straight into dense hardwood, breaking material apart below ground level. The motion feels relentless, chewing through fiber and resistance alike. What once stood firm collapses quickly, turning solid stumps into fragmented ground. In moments, the surface is left clean and workable, ready for whatever comes next. Paired MB track tractors handle wood transport with control taking priority over speed. Heavy logs move steadily across forest ground as trailers remain aligned and balanced behind them. Power flows evenly through both drivetrains, keeping loads from twisting or surging under tension. That stability protects the internal structure of the timber long before it reaches processing. The movement feels deliberate, almost synchronized. Spacing stays consistent through turns and uneven ground, preventing binding that could stress both machines and cargo. Together, the convoy advances at a calm, unbroken pace, a reminder that transport quality matters just as much as the cut itself. Logs don't move randomly in Austria. Every felled tree follows a planned path toward Papierholz Austria's mills, guided by decisions made long before transport begins. Within managed forests, timber is selected with purpose, lifted cleanly by forwarders, and staged in a way that preserves volume, instead of sacrificing it to haste. That early control determines how much usable wood survives the journey. Timing becomes just as important as movement. Trucks arrive in coordination, reducing drying losses and keeping moisture where it belongs. Each load travels with intent, not delay. At the sorting yards, order takes over. Logs are graded, separated, and directed with precision. Conveyors feed processing lines smoothly, maintaining consistent fiber quality from forest to mill. Wooden cable drums take shape through a process focused on balance rather than speed. What matters most isn't how quickly each piece comes together, but how well the finished drum holds its form under pressure. These structures are expected to support long-term static weight, endure repeated rolling, and remain stable even as tension pulls from multiple directions. Every decision made early quietly influences how long the drum will last once it enters service. Production begins with circular wooden boards chosen for consistency. Uniform diameter matters here, not for appearance, but for how forces distribute once the drum is loaded. When the flanges rotate, even minor irregularities can translate into wobble, drag, or uneven wear. Precision at this stage sets the tone for everything that follows. Drilling patterns define the internal alignment. The spacing may seem subtle, but it determines whether the flanges stay centered under weight or begin to drift over time. A drum that rolls clean across the floor depends on geometry decided long before cables ever touch the surface. Attention then shifts to the central barrel sections. Their dimensions must complement the flanges exactly, creating a unified structure instead of separate components simply held together. Width, thickness, and fit all influence how the drum absorbs stress during lifting and movement. Edges are refined to minimize splintering and reduce friction. Smooth surfaces protect both the cable and the workers handling it, especially during repeated winding cycles. Some drums receive clear markings that identify size, capacity, and load limits. In industrial logistics, that information prevents costly mismatches once heavy cable begins pulling outward with constant force. Before completion, handling tests confirm stability. Rolling behavior, balance, and stacking safety are all observed. When a full-size wooden drum moves smoothly without resistance, it signals that everything underneath is working together. The final result is simple but dependable. A wooden carrier built to endure transport, storage, and repeated use without warping or losing alignment. Quiet precision gives it strength that lasts far beyond the workshop floor. Hundreds of precision-cut components come together at MADEM as industrial reels take form, built to withstand constant tension and uninterrupted rotation. These assemblies aren't designed for brief use, but for long hours under load, where balance becomes just as important as strength. Steel discs, hubs, and side flanges are brought together with careful alignment. Even slight variation can shift rotational behavior once material begins pulling outward. The core structure settles first, forming a stable center that prevents movement from developing later during operation. As the outer plates are added, the reel's presence becomes unmistakable. Weight builds, yet the structure remains composed. There's a moment when everything aligns, not forced, not rushed, just controlled strength finding its shape. Fasteners draw the frame together evenly, allowing force to distribute across the body instead of concentrating in one point. That balance helps the reel remain stable at speed, reducing vibration and long-term fatigue. Before completion, spacing and symmetry are checked again. Reinforcement adds confidence, keeping deformation in check even under continuous strain. Despite the scale, nothing resists the process. The structure holds firm. Final checks focus on motion. The reel turns cleanly, smoothly, without hesitation. A clear sign it's ready for sustained work, where reliability matters more than anything else. What gives oak tanks and large format casks the strength to quietly guide wine through years of aging at Tannery Picard isn't a single detail, but a long relationship between material, time, and restraint. These vessels aren't meant to impress through motion or sound. Their role is patience, holding, breathing, and supporting transformation that unfolds slowly in the dark of the cellar. Everything begins with carefully selected oak staves chosen for consistency and long-term stability. Each piece carries its own grain pattern and density, shaped with attention so thickness remains uniform from end to end. That balance matters deeply once thousands of liters of wine press outward. Even distribution of pressure allows the vessel to remain calm under load, resisting distortion while preserving flexibility. As curved sections come together, the structure begins to suggest its final presence. The circle closes gradually, not through force, but through cooperation between wood fibers, responding to pressure. There's a steady confidence in the way the body draws inward, forming a shape that feels inevitable rather than imposed. Steel hoops appear to support the growing form, securing the oak while still allowing it to move naturally. Their placement influences how compression travels through the vessel. Too much tension in one area could disrupt balance elsewhere, so the structure is allowed to settle into itself gradually. The oak tightens, not rigidly, but with intention. Controlled internal fire follows, introducing heat to the inner surface. The warmth moves evenly across the wood, opening its structure and preparing it for long contact with wine. Exposure is carefully moderated. The goal isn't dominance, but dialogue, allowing oak to contribute subtle character without overwhelming the liquid it will one day hold. Heat penetrates deeply enough to shape flavor potential, yet gently enough to preserve strength. Openings are formed and reinforced, creating access points for filling, inspection, and maintenance over decades of use. As the vessel continues to take shape, alignment remains a constant focus. Walls are observed for symmetry. The base must sit stable under immense volume. Each adjustment protects the vat's ability to endure repeated cycles of filling, aging, and emptying. Additional bands reinforce the form, locking geometry into place. These supports help the oak withstand sustained liquid pressure over time, preventing slow deformation that could compromise balance years later. The vessel now feels grounded, heavy, solid, and dependable. Final finishing refines edges and joints, encouraging smooth internal circulation. At this scale, it becomes easy to forget that no concrete or steel carries the load. The work is done entirely by wood, responding quietly and continuously. Before entering the cellar, final inspections confirm structural integrity and balance. No two vats are identical, yet each reflects strict dimensional control rather than visual uniformity. That quiet reliability is why wineries place such trust in these vessels. EWD's circular saw lines at Sagework Holtz Hahn are configured to manage both volume and variation within a single, uninterrupted workflow. The system isn't built around one ideal log size or one production target. Instead, it's designed to accept whatever the forest delivers and keep material moving forward without hesitation. From the moment roundwood enters the line, everything points toward continuity. The layout itself reflects that priority. Each section connects naturally to the next, minimizing pauses and eliminating unnecessary handling. Logs move through the cutting stages as part of one continuous motion rather than a series of stops. That consistency allows the mill to maintain rhythm, even as incoming timber changes in length, diameter, and structure. Handling lengths from 2.5 to 13 meters gives the operation uncommon flexibility. Construction timber, industrial stock, and high-volume cutting can all run through the same line. Mixed deliveries no longer require separation before processing. Instead of forcing uniformity upstream, the system adapts downstream. That approach saves time long before cutting even begins. At the center of the operation sits the double-shaft circular saw line, running in constant rotation. Rather than accelerating and decelerating with each log, the saws maintain stable momentum. This continuous motion keeps cutting forces predictable, even as diameters fluctuate. When resistance stays consistent, accuracy improves, and wear remains controlled across long shifts. Following the main saw line, the trimming system maintains that same sense of flow. There are no abrupt transitions where material hesitates or stacks. Each stage supports the next, carrying timber forward smoothly, so momentum is never lost. It's a design that treats movement itself as a form of efficiency. Roundwood enters the line with controlled orientation, allowing flexibility in how logs are presented. Depending on characteristics such as taper or butt shape, feeding can occur top first or butt first. This adaptability becomes crucial when dealing with natural variation. No two logs behave the same once cutting begins, yet the system absorbs those differences without disruption. Diameter tolerance is equally broad. Tops can measure from 120 to 600 millimeters, while butt ends reach up to 700 millimeters. That range allows the mill to process mixed species and diverse growth conditions within a single production run. Instead of slowing output to accommodate variability, the line simply continues. Cutting paths adjust automatically to maintain stable chip removal. Chips exit smoothly, preventing buildup that would otherwise alter cutting resistance. When chip flow remains consistent, the saws encounter fewer shocks, and feed speed stays uniform. Even with logs of vastly different profiles, the line shows no visible hesitation. That steadiness becomes especially noticeable as dimensions change. A thick butt transitions to a slimmer top without altering the pace. What would normally force a pause simply passes through. The system doesn't react, it absorbs. The reduction line ZE2PF 19DWK/6 to 700 manages primary breakdown with the same philosophy. Both shortwood from 2.5 to 6 meters and longwood up to 13 meters move through under frequency-controlled feed speeds ranging from 30 to 100 meters per minute. Rather than locking production into a single tempo, the system adjusts fluidly, matching feed behavior to material demand. Sideboards are generated efficiently, with up to 3 boards per side emerging from the pre-cut zone. Maximum widths reach 380 millimeters, supporting strong recovery without sacrificing stability. The pull through the cutters feels measured, firm, but controlled, as if resistance is anticipated rather than reacted to. Secondary cutting adds further capacity. With height limits up to 370 millimeters, the line accommodates both side goods and thicker follow-up sections. Structural timber dimensions pass through without rerouting or secondary handling. That ability keeps production consolidated instead of fragmented across multiple systems. Flexible cutting modes allow switching between stock first and top first processing, depending on order demand. This adaptability becomes critical when product requirements shift mid-shift. Instead of stopping the line, adjustments occur within the flow, keeping output responsive without breaking continuity. Throughout every stage, alignment control plays a quiet but decisive role. Centering stability keeps timber tracking true as volume increases. Reduced deviation means fewer corrections downstream and more consistent trimming results. Small improvements here compound quickly when thousands of meters pass through each hour. What stands out most is how little the system appears to struggle. Uneven profiles, changing diameters, mixed lengths. None of it disrupts the rhythm. Operational stability remains constant, even as input fluctuates. The line doesn't demand perfect material. It's built to keep moving regardless. At Satteric Holzhahn, efficiency isn't achieved by forcing uniformity onto the forest. It comes from designing systems that accept variation and continue forward anyway. In that sense, the EWD circular saw line doesn't just cut timber, it maintains momentum. And in high-volume milling, momentum is everything. After primary breakdown, boards transfer to the OPT IME-SB KO/6 to 120 trimming line. The transfer maintains continuous flow without intermediate stacking. Raw boards between 2.5 and 5.0 meters, with extensions to 6.2 meters via a special box, are prepared for precise edge trimming. Extended length handling supports specialty production runs. Widths range from 100 to 500 millimeters, while thickness varies from 17 to 60 millimeters for sideboards and up to 120 millimeters for secondary cuts. This range allows multiple product classes to run in parallel. Optical measurement runs longitudinally, scanning from both above and below to guide cutting decisions. Dual-side scanning improves dimensional accuracy across varying board profiles. Seeing that data-driven control paired with raw timber feels like strength getting a clear set of instructions. The measurement system supports real-time cutting adjustments without interrupting flow. The trimming system handles mixed feeding of top and butt ends, adapting continuously without pausing the flow. Mixed end feeding minimizes sorting delays between batches. Output reaches up to 48 boards per minute under standard conditions, maintaining consistency even at high throughput. This output rate supports industrial scale demand without compromising alignment. Feed speeds extend from 80 to 360 meters per minute, again managed by frequency control to match material behavior. Wide speed ranges allow fine-tuning for surface quality targets. That speed doesn't come off as rushed, more like confidence built into motion. Throughout the line, the focus remains on stability rather than show. System design emphasizes repeatability over visual complexity. Boards leave the system squared and aligned, ready for downstream handling without unnecessary rework. Consistent edge geometry reduces additional processing requirements. The layout supports both mass production and structural timber demands, giving Holzhahn the ability to switch product focus without reconfiguring the entire line. This flexibility shortens response time to market shifts. It's the kind of flexibility that makes you realize this sawmill was designed for real production days, not ideal conditions. The configuration reflects long-term operational planning rather than short-term optimization. Operators monitor transitions between stages, adjusting parameters to maintain consistent output. Human oversight complements automated control during production changes. The circular saw technology favors durability and repeatable cuts, supporting long production runs. Blade configuration supports stable performance across extended operating periods. Material flow remains continuous, minimizing stops and keeping energy use focused on cutting rather than repositioning. Reduced stoppages improve overall line efficiency. Once everything settles into rhythm, the whole line feels like it's refusing to waste a second. That sustained motion defines the character of the installation. Producing ultra-premium wood pellets at Combustibles Grucci follows a carefully controlled flow from raw timber to finished granules. Locally sourced French wood is selected for consistency, then reduced into uniform chips before drying begins. The temperature stays intentionally low, preserving fiber structure and preventing damage that would affect performance later. That slower drying process quietly shapes how the pellets burn. Once prepared, the material is compressed into dense granules without chemical additives, relying entirely on natural lignin for binding. Screening removes fine dust before packaging, a small step that makes a big difference when pellets reach a stove. Quality checks confirm size, density, and ash behavior before shipment. Treated this precisely, pellets stop feeling like waste fuel and start looking like engineered heat. Operators and automated systems work side by side to produce wood pellets at this plant in France. Raw timber passes through shredding before entering controlled drying that stabilizes moisture levels. That balance determines whether pellets burn evenly or create problems later. Compression transforms the material into dense cylinders, followed by screening that removes fines. Dust has little tolerance in home stoves. Final checks confirm durability and size before storage. The process feels less like manufacturing and more like energy management, keeping heating markets supplied without interruption. Speed alone doesn't keep firewood moving in New Zealand forests. Control does, and the Halverson HWP 140B makes that clear almost immediately. Out here, logs rarely arrive uniform, lengths vary, diameters shift, and bark comes thick with moisture. The processor isn't waiting for perfection. It's built to absorb inconsistency and keep working anyway. As material enters the system, movement stays steady rather than aggressive. Feed rollers draw each log forward, while alignment guides quietly stabilize the cutting zone. That balance allows the machine to prepare wood for clean separation without fighting the shape of the timber itself. Cutting unfolds with measured precision. The saw unit sections logs into consistent firewood lengths, maintaining rhythm even as dimensions change. Each segment moves forward without pause, transitioning directly toward the covered splitting chamber. There's no staging, no buildup, just continuous flow. Inside the splitter, hydraulic force works with the natural grain of the wood instead of against it. Pieces separate cleanly, forming uniform firewood ready for stacking. That direct handoff between cutting and splitting keeps interruptions low and momentum intact. The result is productivity that doesn't come from pushing harder, but from staying composed. In New Zealand conditions, where moisture, grit, and debris test equipment every day, the calm reliability matters. Watching the processor hold its rhythm here says more than any specification ever could. Operators rely on the RAB-AUD XY-Log 800 to manage cutting length and splitting force without constant adjustment. Logs are set into position and guided toward the circular saw, where consistent cuts produce uniform sections before splitting begins. Fixed-length cutting keeps the workflow predictable, and that precision saves real time once volume starts building. Each section moves straight into the splitting unit, where hydraulic pressure breaks the wood cleanly and efficiently. Finished firewood transfers onto the conveyor without hesitation, keeping material moving forward instead of piling up. There's nothing flashy about the process, just dependable output. In real working conditions, the XY-LOG 800 stays focused on a single purpose: producing reliable firewood, cycle after cycle.